Power supply constraints. In this video, we are going to see about power supply constraints. Because portable computers have unique characteristics as a result of their portability, they have unique power systems as well. Portable computers can use either of two power sources, batteries or AC power. There are many different sizes and shapes of batteries, but most of them are nickel-cadmium, that is NiCad, lithium-alcon, that is LiLON, or nickel metal hydrate, that is NiMH. All of these perform equally well, but NiCad batteries can be recharged only a finite number of times. After a time, they develop a memory and must be recharged on a special deep charging machine. NiMH and LiLON batteries don't usually develop a memory and can be recharged many times, but they are little more expensive. Some of the much smaller handheld or palm-top computers can use any of these types of battery, but a few vendors such as Hewlett-Packard took a more common-sense approach. They designed their handheld to use standard AA batteries. Most notebook computers can also use AC power with a special adapter that is called an AC adapter that converts AC power into DC power. The adapter either is integrated into the notebook, that is as on some compact notebooks, or is a separate brick with a cord that plugs into the back of the laptop. Another power accessory that is often used is a DC adapter, which allows a user to plug the laptop into the power source inside a car or on an airplane. These adapters allow people who travel frequently use their laptops while on the road, that is literally. Managing power and removing devices. Being free, no room, with your laptop wherever you want is a great thing. Unplugging from the wall and running on battery power means you can leap through a field of spring daisies holding your laptop instead of being chained to your great desk and low cubicle walls. It also presents an opportunity to manage devices and how much power they consume, as batteries don't last forever. Finding a way to manage power efficiently gives batteries longer lives and you more time with your daisies. In addition, as mentioned before, laptops were not designed with internal expandability in mind. Most add-on devices are external. Some peripherals can just be plugged in and unplugged, whereas with others you must follow a specific sequence to safely remove the device. This section focuses on power management as well as the safe removal of hardware devices on laptops. Understanding laptop power management. The basic input or output system, that is BIOS, is run when the computer is first powered up. It checks the hardware to make sure there are no major problems, bootstraps the computer, and then hands control over to the operating system. One of the features of most modern BIOS systems is the Advanced Configuration and Power Interface, that is ACPI, also sometimes referred to as BIOS ACPL. First released as an open standard in 1996, ACPI defines common interfaces for hardware recognition and configuration and, more importantly, power management. ACPI has two important power management features. First, it gives control of power management to the operating system. With older versions of power management, control was BIOS related and the user had little control through the operating system. Today, the BIOS handles power management communication between the operating system and the device. Second, ACPI allows power management features that were once only found on laptops to be available on desktops as well. For ACPI to work, the motherboard, CPU, and operating system all need to support the standard. The first Windows operating system to support ACPI was Windows 98. The ACPI standard defines 4 power level states called global states. The global states are computer-wide and there are other device, processor and performance states as well. Battery charging. In this video, we are going to see about battery charging. Most systems use an external AC adapter and battery charging unit, sometimes referred as a brick. To make portable use easier, some systems build the AC adapter or battery charger into the portable computer and use a special polarized power cord for recharging. Just as with desktop power supplies, notebook battery recharging systems must be compatible with the local electrical power source. Most portable computers use an automatically switching recharger, capable of handling either European and Asian 50 cycle 230 volt power or North American 60 cycle 115 volt power. However, a few systems are shipped with a single voltage recharger, requiring that you use a power converter or different recharge if you travel internationally. If the portable computer doesn't appear to be receiving power from either an external or internal AC adapter or battery charger, check the following. Loose or defective line cord. Battery failure. Check the line cord for damage or loose connections. Reconnect or replace the line cord between the wall outlet and the computer or external AC adapter and retest the system. If the system does not start and run correctly, remove the batteries from the portable computer and try to run it from wall current only if the unit will work in this fashion. If the batteries are the problem, the unit should work properly on wall current only. Simply replace the batteries. If both of these tests fails, repair or replace the external AC adapter or computer with the internal AC adapter. Use only manufacturer-approved parts for replacement. Because of differences in battery technology and system boards, internal units from different models of portable computers usually are not interchangeable. Make sure that you replace single voltage AC adapters with the correct voltage for your country or region. Battery replacement. Most batteries in portable computers can be replaced by the user in the field. Generally, replacement batteries fall into two categories: proprietary batteries that are customized for a particular portable computer model. You can purchase these batteries from specialized battery stores as well as from the manufacturer of the computer. Industry standard models that fit into a wide variety of computers and other devices. These batteries can be purchased at most retail stores. Most computers that use industry standard AA and AAA sized batteries are PDAs. Follow this procedure to replace computer batteries. Turn off the computer. Unplug the AC adapter or line cord from the computer. Locate the battery compartment in the unit. It might be secured by a sliding lock or by screws. Remove the cover. Slide or lift out the battery or batteries. If the battery is a flat assembly, it might be held in place by a clip. Push the clip to one side to release the battery. Check the battery contacts inside the computer for dirt or corrosion, and clean dirty contacts with a soft cloth. Insert the replacement battery or batteries. Make sure you insert batteries so the positive and negative terminals are in the right directions. Close the cover and secure it. If the battery must be charged before use, plug in the line cord or AC adapter into both the computer and wall outlet. Check the computer's manual for the proper charge time for a new battery. Unplug the system or AC adapter when the battery has been charged for the recommended time period. Handling and storage. In this video, we are going to see about handling and storage. Nearly all laptops have a hard drive, but not all laptops have both a floppy drive and a CD-ROM drive. Many times there just isn't room for both, and considering floppy drives are particularly obsolete, why have one way? Often there is a drive bay that can be used to hold either drive. If this drive bay exists, users generally keep the CD-ROM drive installed most of the time and leave out the floppy drive. In some cases, the floppy drive is an external device that you connect with a special cable to a proprietary connector. Notice how thin the floppy drive is and how compact the electronics are. laptops don't have the room for the full-size 3.5-inch hard drives that desktop computers use. Instead, they use a small form factor hard drive that's only 2.5 inches wide and less than half-inch thick. These drives share the same interface technologies, that is usually ATA and UDMA, as desktop computers. However, they use smaller connectors. Figure shows an example of a standard hard drive compared to a laptop hard drive. Laptop CD-ROM drives come in many different kinds, just like desktop CD-ROM drives. You can get standard CD-ROM, CDR, CDRW, DVD, DVD-RAM, and probably the most popular option, CD read and write or DVD-ROM drives that can both burn CDs and play DVD movies. It is also possible to get CD-ROM drives that manage to cram a floppy drive into the same drive bay along with the CD-ROM. Often these drives are very small in form factor, that is usually less than half-inch high. Note that the laptop drive is very small, but it has all the functionality of a desktop unit. The drive mechanism and circuits have all been miniaturized to save space. The functionality is basically the same, but the cost is higher. Anytime a component's functionality remains the same while its size decreases, you will notice an increase in price over the standard size item. Cleaning of displays. In this video, we are going to see about cleaning of displays. Portable computers were originally designed to be compact versions of their bigger computers. The life and usefulness of the portable's LCD panel can be extended through proper care and handling. The screen should be cleaned periodically with glass cleaner and a soft, lint-free cloth. Spray the cleaner on the cloth and then wipe the screen. Never spray the cleaner directly on the screen. Also, avoid scratching the surface of the screen. It is relatively easy to damage the front polarizer of the display. Take care to remove any liquid droplets from the screen because they can cause permanent staining. After cleaning, allow 30 minutes to complete drying. The screen should be shielded from bright sunlight and heat sources. Moving the computer from a warmer location to a cold location can cause damaging moisture to the contents inside the housing, that is including the display. It should also be kept away from the ultraviolet light sources and extremely cold temperatures. The liquid crystals can freeze in extremely cold weather. A freeze cycle may damage the display and cause it to be unusable. Running diagnostic software tools. In this video, we are going to see about running diagnostic software tools. The first step in most repairs is to run diagnostic routines supplied by the OEM to identify the cause of the fault. Most equipment is provided with some self-checking routines, which are intended to display at least an error code so that a technician can work more efficiently. Following the attempted repair, diagnostics are typically rerun to confirm the repair is complete. If the diagnostics indicate a problem still exists, the job is not complete. Diagnostic software, either onboard or external, is not always provided as part of the equipment purchase. In the auto industry, the diagnostic software may be included in a separate device that must be purchased to read the diagnostic information from the vehicle. In this case, diagnostics are both tools and software. In cases where diagnostic services are provided by external equipment, the OEM may refuse to sell such equipment to equipment owners or independent repair organizations, thus pushing repair back to the OEM exclusively. If a developer decides to fill the void by manufacturing an independent set of diagnostics, the prohibition against circumvention in the DMCA will likely be used to litigate against the provider of the equipment. In most cases, the threat of litigation is enough to dissuade small companies, that is, entrepreneurs, from entering this market. In most IT equipment, diagnostic routines are provided with the machine and accessible using standard input or output devices. Although this eliminates the need, that is in most cases, for an additional purchase of diagnostic equipment and specialized attachments, the manufacturer can still block access to diagnostics by outsiders in several ways. First, the OEM may deliver diagnostic code updates only under an OEM maintenance agreement. Second, the OEM may deliver a set of diagnostics to independents that are different than those for their own technicians, narrowly meeting legal requirements in some jurisdictions. Similarly, some OEMs block access to corrections to the diagnostic code itself. Third, the OEM may lock access to diagnostic routines using software locks or quasi-hardware locks that are delivered exclusively to OEM technicians. Last and extremely common, the OEM simply claims that the diagnostic software is their intellectual property, that is IP, and the implied threat of copyright litigation generally ends the attempt to access diagnostics without the permission of the OEM. Tools. Repairs usually require some physical tools such as a screwdriver to open cases to access parts. Within the machine, there are commonly other tools needed to remove and replace failed components. Some machines are designed to be accessed by the consumer with common tools, and others are designed to be difficult to access without specialized tools that are deliberately uncommon to that repair by the owner or any non-OEM technician. Buyers should request that proprietary tools be provided as part of the purchase, in much the same way that small wrenches are provided by IKEA to facilitate installation of the products. Antivirus software. In this video, we are going to see about antivirus software. Antivirus or antivirus software, that is often abbreviated as AV, sometimes known as anti-malware software, is computer software used to prevent, detect, and remove malicious software. Antivirus software was originally developed to detect and remove computer viruses, hence the name. However, with the proliferation of other kinds of malware, antivirus software started to provide protection from other computer threats. In particular, modern antivirus software can protect from malicious browser helper objects, BHOs, browser hijackers, ransomware, keyloggers, backdoors, rootkits, Trojan horse, worm malicious LSPs, dialers, fraud tools, adware, and spyware. Some products also include protection from other computer threats such as infected and malicious URLs, spam, scam, and phishing attacks, online identity, that is privacy, online banking attacks, social engineering techniques, advanced persistent threat, that is APT, and botnet DDoS attacks. Handling plug-in or plug-out hardware. In this video, we are going to see about handling plug-in or plug-out hardware. Now that you know about the rules for purchasing a new hardware device, installing it is rather anticlimactic. First, always check the device manufacturer's documentation that came with a hardware device for instructions. Most hardware manufacturers include specific step-by-step instructions that tell you exactly what to do to install or attach the device to your computer. Just follow these steps. Attach the new device to the correct port or slot on the back of your computer. If the device is an internal device, first check the installation instructions to see what you need to install first, the hardware or the software. If you need to install the hardware first, shut down and unplug your computer from the power outlet and follow the manufacturer's instructions for removing the computer's case and installing the device in the correct slot. Turn on your computer and boot Windows. Windows automatically detects the device and installs it on your computer. With some types of devices, some instructions may appear. Follow them as directed. In most cases, installation is handled automatically and you receive a bubble message from the notification area telling you the device has been installed.